Hi. Wow. Look how sharp that nebula is when you turn the PSF all the way up to 8 in AstroSharp, my free Astro-sharpening tool. Wait, what's that? What did you say, little star? What? You're over-sharpened? I've ignored stars at the expense of deep sky objects? You're sad? Oh no. Just don't be upset. I care about you, really I do. You can change, we can all change. I've just figured out a solution. Okay, here it goes. Let's try the PSF slider for stars. Let's dial back PSF to 4. Still a bit too sharp, you say? Okay, how about 2.5? Better? Just right? Awesome. Welcome to Deep Sky Detail. Today I'm going to be going over the brand new feature in AstroSharp, the Dual PSF model. Basically, it's a feature that allows you to sharpen the stars separately from the rest of the DSO. I'm not going to go over the previous features or AstroClean or anything else. So if this is the first time viewing one of my videos, check out the playlist of AstroSharp development to learn all about the cool stuff. Before we begin, what's all this about the title? Is this the last free version of AstroSharp? Well, free for whom? I've been posting things for free on GitHub for a while now, and I will keep doing that. So it will always be free for anyone to use. I would like to upload this as an online tool so that anyone can use on any platform. Here's the thing. That costs money. The updated tool is on this website right now. Previously, it was part of the Shiny free plan, meaning it only had 1 GB of RAM for users to use. That means the online version would crash if you upload anything more than about 500 by 500 pixels. I've gone ahead and paid for an upgrade, meaning AstroSharp is no longer free for me. You can use it online for the next month. I cannot justify continuing to pay for this myself. I am not rich. YouTube does not pay much to small channels like mine. So if you would like to have the online version available, please consider joining my channel or making a donation. If enough people donate, I will continue to support the online version. Note that multi-core and the online version probably won't work. Also, I'm unsure about the size of an image you can use on the online version. I successfully uploaded a binned 2x2 ZWO 294mm Pro image. That's about 10 megapixels at 16 bits. I also was able to upload an 18 megapixel image at 32 bits. The online app crashed when I tried to upload a 47 megapixel image at 32 bits, so I'm not exactly sure how much the app can take. It is probably around 18 to 20 megapixels regardless of the bit depth. The size limit for the Dual PSF model is a bit smaller than the other models, as the Dual PSF model is somewhat more resource intensive. I'm also not sure how many people can use it without it crashing. Also, the app will disconnect from your browser if not used more than 25 minutes. So if you upload an image and forget about it, you won't be able to download the sharpened image if it disconnects, and we'll have to resharpen it. But please consider joining as a channel member if you'd like to see more of this. Currently, the web version is open to the public, but I may make it available to only channel members depending on how much traffic the app gets. I'm just not sure how much the current plan can take, and if it is constantly crashing due to too much traffic, then it would make sense to limit its use a bit. But the GitHub version will always be free and available like always, and the web version is currently free for you too. Okay, back to explaining new features. Real quick, you might notice that below your output image there is a histogram in red line. The histogram is a histogram of your processed image. The red line relates to the star mask, and I'll get to that in a bit. Okay, to make the Dual PSF feature work, make sure you click Dual PSF under the Choose Model drop-down menu. Then you can sharpen the stars and DSOs separately. Pretty cool. You can see here that the stars are basically unchanged even though the PSF for the DSO is turned up to 8. Let's compare a full PSF 8 model by turning up the stars to 8 as well. You can see that over-sharpening the stars makes them sort of bloated and ugly. Not good, not good. So how does this work? How does this PSF star slider work? Well, basically there's a star mask working in the background that helps the tool distinguish between stars and DSOs. You can actually choose the star mask as a model if you'd like and download it to use it in other software. But the star mask model by itself is really resource intensive at the moment. It's optimized for working in the Dual PSF model, but by itself it's still a work in progress. So getting a full image star mask by itself might not work for everyone unless you have a lot of RAM. The star mask has quite a few parameters attached to it. They're the ones on this side. I think the default parameters should make the tool work in 99% of the cases, but sometimes you might have to play with things a bit. For example, if you find that the Dual PSF model isn't controlling the stars at all, meaning it's acting just like the regular PSF model, then something might be wrong. The first thing to do, aside from checking to make sure you have the right model selected, is to choose the star mask model and look at the preview. If the star mask looks all crazy, try adjusting this fix mask parameter to a slightly higher number. If you then see a normal star mask, great. Too high of a number, though, may also break the star mask. A good value is probably around 0 to 2 in most cases. Alright, so this top parameter is star sensitivity. A higher sensitivity means it will detect fewer stars. Lower the sensitivity, and it will start to detect more. However, it may also start detecting bright parts of your DSO, so be a bit careful. You can use any number between 0 and 100, but reasonable values will usually be above 98 or so. The next two parameters are blend values. These determine how the PSF model for the stars and the PSF model for the DSO blend together. I think the default values are pretty good for most cases. Behind the scenes, it controls the stretch of the star mask. The stretch is the red line overlaid on the histogram. Keep in mind that the red line only applies to the star mask. It does not stretch the processed image in any way. So anyway, the star mask initially is just a bunch of ones and zeros, meaning it's black or white. It then gets feathered or blurred a little bit. Then these parameters determine how the blurred star mask gets stretched. The first blend parameter kind of determines how far the curve shifts to the left. The second number determines how much the curve gets pushed to the right. Together they interact. What you want to see in the star mask is white where the stars are. The white should extend past the stars a bit, then it should quickly fade into black. The fade into black can be pretty quick. Let me overlay the star mask preview on top of the original image so we can get a good sense of what is going on. You can see that the white completely covers each star and even extends a few pixels out. Then there is a bit of gray before it transitions to black. This is what you want to see in most cases. Remember, the blend 1 parameter should probably be a lot lower than the blend 2 parameter. Otherwise it won't work. Let's try breaking it by making it the reverse. See? I told you, it just doesn't work this way. Let's also talk about multicore too. In order to use it, when still in preview mode, you need to click multicore, then update sliders before clicking full image. If you click multicore, then full image right away, it won't actually use multicore processing, and this is true for any model that you choose. Let's quickly look at some results. Here's a soft image of the Heart of the Heart Nebula, sharpened with a single PSF of 8, and with dual PSFs of 2.5 for the stars and 8 for the nebula. Thanks for watching.